Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to work out the angle of inclinations of a line. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. To find a gradient of a line, so we just use rise over run. So let me just construct a right angle triangle first. So let's just construct a right angle triangle here. So this is rise and this is run. So we know that the gradient of a line, so m is rise over run. But then we know that the graph is going this way. So therefore the gradient is positive, which is greater than 0. Now don't forget, if the line going this way, so we have negative m, okay? That is m is less than 0. So if we have a horizontal line, that means the gradient is 0. So please keep that in mind for me, okay? But then we know that rise over run, if you think about it, let's have a look at this angle here. This is angle theta. So rise is opposite of this angle. So just write O. And run is next to this angle. So which is adjacent, which is A. So now we have O and A. So we have O and A. So therefore, to find the angle theta, so we use tan. So therefore, tan of theta is equal to opposite over adjacent. So opposite is the rise. And the adjacent, which is A, which is run. So rise over run. But then because the line gone this way, so we just have a positive gradient. So in another word, the angle theta is acute, if you like. So therefore, the angle theta here, okay, is called angle of inclinations. So the angle of inclinations is measured from the positive x-axis and it goes anti-clockwise. Okay, so please keep that in mind for me. So in this case here, the angle of inclination is acute angles because the gradient is positive. Now, if we have a negative gradient, so we know that m equal to tan of theta, or tan of theta is equal to m, if you like. So the angle theta is the angle of inclination. So this is here. So this is angle theta. So we know that angle theta is obtuse. In another word, the gradient is negative. So to find the angle of inclination in this case here, so what we do, we just go inverse tan of the gradient. We ignore the negative sign. And then we just go 180 minus the acute angle. So let me just go through a couple examples and you will know how to do it. So first one. So we know that m is equal to tan of theta. So the theta is the angle of inclination. So from here to here is the inclination. So that is 63 degrees and 26 minutes. So therefore, to find the gradient of this, m is equal to tan of 63 degrees and 26 minutes. So what I do now is I just put that on a calculator. So I just go 10 and make sure your calculator is on degree modes, okay? Just keep that in mind. So 10 of 63 degrees and 26 minutes. Close bracket. So there you go. 1.9998 and so on. So we just round up to whole number. So that give me 2 or 2 decimal place to give you 2.00, right? So you go, therefore, m is equal to 2. So there you go. And you can see that the gradient of this is positive because the line gone this way. Okay, so please keep that in mind for me. Now, second example. So we know that the gradient m is equal to tan of theta, or tan of theta is equal to gradient m. Okay, and in this case here, we know the angle theta, that is the angle of inclination, is 142 degrees and 49 minutes. So therefore, the gradient should be negative. And you can see from the graph as well, okay? So m is equal to tan of 143 degrees and 49 minutes. So that will give me, so I just put that on a calculator now. So just go tan of 143 degrees and then 49 minutes and close the brackets. So that is negative 0.7314 and so on. So we just round up to 2 decimal places will do, okay? So negative 0.73. So the answer is negative 0.73. So therefore, the gradient is equal to this, okay? Next one. So remember the angle of inclination is m is equal to tan of theta. Okay, so keep that in mind. Or I can write as tan of theta is equal to m. Now to work out the angle of inclination passing these 2 points for part A. So we just, first of all, we just need to work out the gradient first, okay? The gradient, so we know that the gradient is equal to y2 minus y1 over x2 minus x1. So let me just label this first so you don't confuse. So this is x1, y1, x2, y2. So now we just substitute that in the formula. So that is equal to y2 is 4 and then minus y1, which is 2, over, so x2 is 3 and minus x1, which is 1. So 4 minus 2 is 2 and 3 minus 1 is 2. So that is equal to 1. To work out the angle of inclination, so we should know that is acute angles because the gradient is positive, okay? Because the line is going this way. So if you think about it, we have the axis, x and y axis here. And the gradient is 1. That means the line goes somewhere around like that, okay? So to find this angle here, so which is acute angle. So keep that in mind, okay? So now, tan of theta is equal to m, which is m is equal to 1. So therefore, theta must be tan inverse of negative 1. So if you put that on a calculator, you should get 45 degrees. So let me just write this down. So therefore, the angle of inclination is 45 degrees. So there you go. Part B. So first of all, again, we just need to find the gradient first because tan of the inclination's angle is equal to the gradient. So let me find the gradient of this first. M is equal to y2 minus y1, which is y2 is this, y1 is this. So y2 is 2a minus y1, which is 5a, over x2 minus x1. So x2 is 4a, so let me write this down, and minus x1, which is 2a. So there you go. So now we're just collecting like terms. So 2a minus 5a is negative 3. Otherwise, you can just go 2 minus 5, put that on a calculator, and you should get negative 3. So that is minus 3a, or negative 3a, over, so 4 minus 2 is 2. So that is 2a. So now I just cancel this out. So therefore, the gradient is equal to negative 3 over 2. Now to work out the angle of inclination, so we know that it is an acute angles because its gradient is negative, okay? Keep that in mind. Otherwise, so the gradient is negative, so the graph is something like this, okay? So then to work out the angle of inclination, start from positive x-axis and it go anti-clockwise, okay? So this is theta here. So it's obtuse angle. So to work this out, first of all, we can ignore the negative sign for gradient. So we find the acute angle first, and then we go 180 minus that, okay? So let me just write this down. So tan of theta is equal to m, which is negative 3 over 2. So then let me just quickly ignore the sign first. So I'm going to find the acute angle. So I can ignore the negative sign, inverse tan of 3 divided by 2, or 3 over 2 if you like, or 1.5, okay? So that gives me 56.309 and so on. I press the DMS button. So that is 56 degrees and 19 minutes. Now, if you put inverse tan of negative 3 over 2, so you should get a negative answer. So this means that it's this angle here because it's opposite side, so it gives you a negative, okay? But I ignore the negative sign, so it gives me just the reference angle, okay? Just an acute angle. So in another word, this angle here is 56 degrees and 19 minutes. That's what that meant, okay? So if you put the negative side there, it should give you negative. So that's why it goes that way. Okay, just keep that in mind. And now this angle here is exactly the same as this angle because opposite angles are equal. So 56 degrees and 19 minutes. So now to work out angle theta, so theta is equal to 180 minus the acute angle or the reference angle, if you like. So 56 degrees and 19 minutes. So that will give me, so I just go 180 minus the answer. So press the DMS button. So there you go, 123 degrees and 41 minutes. So 123 degrees and 41 minutes. So there you go. This is the angle of inclinations. So please keep that in mind. Third one, to find the angle of inclinations for this line here. So first of all, we need to find the gradient of the line first. Now, this form here is general form. So therefore, we need to convert that into gradient intercept form first. So we can find the gradient from there, okay? So now I just rearrange this, becomes y is equal to mx plus c, okay? So then we can find the gradient. So to do this, what I do, I just move this on the right and I move this on this side as well. So that will give me 5y. So 5y is equal to negative 2x, because 2x, I move that side, becomes negative 2x. And then we minus 5 becomes plus 5 because we move on the other side. So change the side, okay? So now what I do, I just divide this by 5 and I divide this by 5. I divide this by 5. So this cancel out. So therefore, y is equal to, so I can just write in y equal mx plus c. So that is exactly the same as negative 2/5 x plus 1. So there you go. So now the gradient is negative 2/5. So let me write this down. The gradient of this is negative 2/5. So we know that the angle of inclinations is obtuse, okay, because the gradient is negative. So therefore, we just write tan of theta is equal to m, or m equal tan of theta. So therefore, tan of theta is equal to negative 2/5. So if you think about it, the negative gradient, it means the line goes this way, and you can even see clearly is obtuse angle. So to work this out, I can simply ignore the sign of the gradient. I just go 180 minus inverse tan of the gradient. So therefore, the angle theta, that is the angle of inclination, is equal to 180 minus, we ignore the sign of the gradient, okay, inverse tan of 2/5. So that should give you the angle of inclinations. So let me just put that on a calculator. So I just go 180 minus inverse tan of 2/5. And I just close brackets. So there you go. That's the answer, but we just round up to nearest minutes, okay? So that would give me 158 degrees and 12 minutes. So therefore, the angle of inclination is this. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first one. So we know that the angle of inclination, that is tan of theta, is equal to m. Okay, so first of all, we need to find the gradient first. So the gradient of this point is m is equal to y2 minus y1. So y2 minus y1, 7 minus 3 over the x2 minus x1. So x2 is 5 and x1 is 2. So x2 minus x1. So that will give me 7 minus 3 is 4. And then 5 minus 2 is 3. So otherwise, just put that on a calculator, okay? So now to work out the angle of inclination. So we know that tan of theta is equal to m. But we know that m is 4/3. So tan of theta equal 4 over 3. So therefore, theta must give me tan inverse of 4 over 3. So now I just put that on a calculator. So inverse tan of 4 divided by 3. So 53 degrees and 8 minutes, okay? So therefore, theta is equal to 53 degrees and 8 minutes. So there you go. So part B, again, we just need to work out the gradient first, okay? So don't forget. So the gradient of this is equal to y2 minus y1. So b minus 3b over x2 minus x1. So that means 2b minus negative b. So b minus 3b is negative 2b. So negative 2b over. So we have a negative and a negative become positive. So 2b plus b will give me 3b. So 3b. Of course, we can cancel this out. So therefore, the gradient is negative 2 over 3. So we know that the gradient is negative. So this means that the line is going something like that, okay? So the angle should be obtuse, greater than 90 degrees and less than 180 if you like. So now to work this out, so we just find inverse tan of 2 over 3. We ignore the side and the angle of inclination is 180 minus the answer, okay? Keep that in mind. So let me just write this down. Theta is equal to 180 degrees minus inverse tan of the angle, 2/3. So that will give me, so just go 180 minus inverse tan of 2 over 3. So there you go, 146 degrees and 19 minutes. 146 degrees and 19 minutes. So there you go. Last one. So to work out the gradient of this, so we need to rearrange it. Becomes y is equal to mx plus b. So we can work out the gradient from there, okay? So to do this, I rearrange this by moving the negative y on this side. So it becomes positive y. So in another word, 4x plus 3 is equal to y. So I can rewrite like this. Y is equal to 4x plus 3. So remember, y is equal to mx plus c. So therefore, the coefficient of x, which is m here, and this is 4. So therefore, the gradient is equal to 4. And we know that tan of theta is equal to m. So m is 4. And we know that the angle is acute angles, okay? Because it's positive gradient. So theta is equal to tan inverse of 4. So therefore, theta is equal to, so I just go inverse tan of 4. Close brackets. So there you go. 75 degrees and 58 minutes, okay? So 75 degrees and 58 minutes. So there you go. I hope you got all of them correct. Thank you so much for watching. Bye.